Hey everyone, today we're diving deep into the world of threads, those little software wonders that can supercharge your programs. Imagine you're downloading a massive file while browsing the web. Without threads, your browser might freeze up until the download is complete. Threads change the game by letting your computer handle multiple tasks at once, like downloading in the background while you keep browsing smoothly. Think of threads like pit crews in a Formula One race. Each crew member has a specific job, like changing tires or refueling. They work simultaneously to get the car back on track as quickly as possible. So, buckle up as we explore the fascinating world of threads and discover how they can take your programming skills to the next level. Alright, let's pop the hood and see how these threads really do their magic. In simple terms, a thread is a lightweight process, a smaller unit of execution within a larger program. Each thread has its own instruction pointer and stack, which stores data specific to that thread. Think of a process like a big factory with different departments, each responsible for a specific part of the production process. Threads within the same process share the same memory space, allowing them to access and modify the same data. For example, one thread could be responsible for rendering graphics, while another handles user input. Threads can also communicate with each other using various mechanisms, like shared memory or message passing. It's like having a walkie-talkie system within the factory, allowing different departments to stay in sync. Now that we've got a handle on how threads work, let's talk about how you actually use them in your programs. That's where threading libraries come in. These handy libraries provide a set of functions and APIs that make it easier to create, manage, and synchronize threads. Think of threading libraries like toolboxes for working with threads. One popular type is the kernel-level threading library, tightly integrated with the operating system kernel. Examples include the POSIX threads, pthreads library, and the Windows API for threads. Another type is the user-level threading library, which operates entirely within the user space. Choosing the right threading library depends on your specific needs and the platform you're developing for. Section 4. Efficiency Boost. Why threads make your programs faster. Threads can significantly boost your program's performance, making it faster, more responsive, and capable of handling more tasks simultaneously. Remember that analogy of downloading a file while browsing the web? With threads, you can split that download into multiple concurrent downloads. This means your browser can keep responding to your clicks and scrolls while the file chunks download in the background. Threads are also a game changer for applications that perform computationally intensive tasks, like video editing or scientific simulations. By dividing these tasks into smaller chunks and processing them concurrently, you can significantly reduce the overall processing time. They also improve resource utilization by allowing multiple threads to share the same process resources. This is especially beneficial for applications that handle many short-lived tasks, like web servers or database systems. Section 5. The good, the bad, and the thready weighing your options. Now before you go thread crazy and start multi-threading everything in sight, there are a few things to keep in mind. While threads offer significant advantages, they also introduce some complexities and potential pitfalls. One of the biggest challenges with threads is synchronization. When multiple threads access and modify the same data, you need to ensure that they don't interfere with each other and create data inconsistencies. This requires careful synchronization mechanisms, like mutexes or semaphores, to control access to shared resources. Another potential issue is deadlock, which occurs when two or more threads are blocked indefinitely, each waiting for the other to release a resource. Finally, debugging multi-threaded applications can be more challenging than debugging single-threaded ones. Specialized debugging tools and techniques are often required to effectively debug multi-threaded code. Section 6. Threading Mastery. Key takeaways for coding champions. Congratulations, you've made it to the end of our threading adventure. You've learned what threads are, how they work, and how they can make your programs faster and more efficient. Here are the key takeaways to remember. Threads are lightweight processes that allow your programs to perform multiple tasks concurrently. Threading libraries provide tools and APIs for creating, managing, and synchronizing threads. Threads can significantly boost performance, especially for I/O bound and computationally intensive tasks. Synchronization and deadlock are important considerations when working with threads. So go forth, embrace the power of threads, and unleash the full potential of your code.